Alright, today we're going to be learning about function symmetry. You might already know symmetry from Algebra 1 or Algebra 2, but today we're going to talk about specifically the functions. What does it mean to have symmetry with a function? So our essential question is going to be, how do you describe symmetry of functions verbally, graphically, and algebraically? So this is one that we're going to be focusing algebraically, and we're really going to be looking at graphically. And now if you're in my class, we go over the verbal a lot. But if you're doing this just online, you're getting a video just to help you out, then the verbally, you're going to have to kind of take care of that yourself, repeating the words that I use. So we're going to start with getting the main vocabulary of what we need to do this time. So we have even functions and odd functions. So we're going to start over here with even functions. And even functions mean that you are symmetric across the y-axis. So you are symmetric across the y-axis. Let's get a really good example up of this. Now this is just going to be a sketch. I know oftentimes I try to get people to be perfect, but today a sketch is going to be fine. So there's a lot of different things I can do here, but I think this is going to be pretty clear explanation. That is symmetric across the y-axis. I know maybe, sure, I should move it just a tiny bit left, but it doesn't look like it's going to let me do that. But yeah, that's pretty good. It means symmetric across the y-axis. So basically, I'm taking this, this half of it, and I am folding it across my paper using my y-axis. And I'm folding it across the paper and it looks the exact same. Think of a mirror. Our other type of function that we can have is an odd function. So this one, we're saying we are symmetric about or around the not the y-axis, I'm reading over here, but we're talking about symmetric about the origin, not an axis, the origin. And a good example of this is going to be a cubic function. So basically what we're doing is we're using this origin as a pivot. We are taking this little bit here and I'm moving it clockwise, and that is symmetric about the origin. So here's a couple ways you can kind of remember this. Even function, that is going to be a fold. Odd functions are going to be a rotation. And here's what we're going to be doing. We're going to be using these two definitions. We're going to get these, this little extra part of the definition. We're going to take our function and we're going to substitute negative x into it. And if this is an even function, we're going to expect to get f of x out. For odd functions, we're going to start the exact same way. We're going to take our function, we're going to substitute negative x into it, and we're going to expect to get negative f of x out. We'll talk about what that means in our next example. But really what we're saying is, okay, my x is negative, but my y turns out to be positive. Sorry, that should say negative right there. And over here, we're saying, okay, my x is negative and my y is negative. So that's how you can look at it in terms of coordinates. Remember, f of x means y. So let's jump into our example. we're going to determine the symmetry of this function. We're going to start with our graph, then we're going to move it into the algebraic notion of this. So f of x equals x cubed minus 2x. So we're going to start by graphing. So to graph, you're going to want to go home, new document, add graphs. And now we're going to type in x cubed, not xx, x cubed, click to the right, and then minus 2x. So we're going to take a look at this graph, and we're going to say, okay, from my graph, I can say, all right, maybe this is odd. So we're going to say, it looks odd. It looks like around this origin, I can take this graph here, this part of the graph, and just rotate it around, and it'll look the exact same. So when we do our algebraic, we're going to take our function f, and we're going to substitute negative x in. And we're going to say, okay, so we're going to get negative x cubed minus 2 times negative x. From here, what you want to do is simplify. So negative x cubed, that gets me negative x cubed, like that. Minus 2 times negative x, that gets me positive 2x. Now you can stop here and think one of two things. We're testing, we are assuming that this is odd. So we're going to come back over here and we're going to think about this definition right here that we have under odd. We're going to expect to get negative f of x. And I said I would talk about what that meant. So that can be one of two things. The first thing is it could mean negative f of x, and that's the way I'm going to go forward. The other thing that you might want to say here is that all signs change. So after you substitute in negative x and you simplify, we're going to say all signs change. So let's take a look now. I'm looking at my signs. Well, this one is negative. This one's positive. Over here, this one was positive, and this one was negative. So all my signs change, which confirms this is odd. But I want to go through the full algebraic portion and see what we can do. So negative, let me get rid of those circles right there. Well, that's a big eraser. Nope, still big. Here we go. All right. I might want to just redo that plus sign. Okay. So now that we have negative x cubed plus 2x, you want to recognize that you can factor out a negative. So now this becomes positive x cubed and minus 2x. And well, x cubed minus 2x, that's exactly what I have up here. Well, a substitution I can make for that is f of x. So I'm going to say negative, and this part is my original function, f of x. So algebraically, we show that we started with this and with f of negative x, and we finished with negative f of x, which proves, back to our definition, that we do have an odd function. So that proves it. We looked at the graph, we're like, okay, yes, this looks odd. All right, and then we did it algebraically and we confirmed, yes, the function is odd. On to our next example. So over here we have g of x equals x to the fourth plus 2. Let's start with our graph. Now if you're new to the Inspires, make sure you're looking at those keystrokes that get highlighted. So we're going to go home, we're going to go to new document. It's a good way to do it. I'll show you another way on our next problem. And when it says, do you want to save the unsaved document? What are you saying to drugs? You say no to drugs, so no. We want to add a graph. All right, and so we go x to the fourth, This is what I'm talking about. Notice how this is highlighted in red. So follow those keystrokes and then plus 2. Enter, and there is our graph. All right, there's our graph. And what we're going to do is determine if this is even or odd. Well, for my graph, this is my y-axis. It looks like it gets folded over, so we're going to say maybe this is even. All right, now we're going to come over here to our algebraic side, and we're going to go g of negative x. So g of negative x, that's what we're taking a look at. And so this is going to say negative x to the 4th plus 2. A good way to think about negative x to the 4th, well, we're only worried about the sign, really. So negative times a negative times a negative times a negative. That is a positive x to the 4th, and then nothing changed to 2. So I can look at this. We substituted in negative x here. We're getting out x to the 4th plus 2, which was equivalent to our original function, g of x, which is, this is the definition of an even function, this right here. So this confirms, yes, we are even. So we can say, yes, the function is an even function. We just confirmed it algebraically. All right, let's graph this one. Again, going through the calculator, I said I'd show you a different way to do it. All right, so if you already have a graph up, you just want to delete it and put in another one. So go hit tab. This is the way you can get other functions up. So you can type in like x and it gives you another function. Or hit tab, press up, delete the one that we just made, and press up again and delete that. All right, now we can put in our function that I'm giving you, x cubed minus 0.5 x squared minus 3x. Enter. All right, that's what we're looking at. That's what we wanted to see. So looking at this graph, it looks even. It looks like you can use this as a pivot and just rotate it around, and that'll be, sorry, not even, odd. It looks odd. You're going to use this pivot, rotate it around, looks like an odd function. So that's what I'm thinking right now. We're going to confirm or dispute that algebraically. So again, we're going to use h of negative x. This is how you always start, making that substitution for x. So I have negative x cubed minus 0.5 negative x squared minus 3 times negative x. And then you just want to go through and simplify. Negative x cubed minus 0.5 times x squared plus 3x, negative times a negative. So if we keep going, negative x cubed minus 0.5 x squared plus 3x. So we said, okay, maybe this one is an odd function. So we're going to see, okay, do all of my signs change? So negative x cubed, check. Well, minus 0.5x, that one doesn't change. But then plus 3x, that one does change. Well, all of the values need to change. If all the values don't change, then it does not confirm that we have an odd function. In fact, this is neither even nor odd. Even though our graph over here looked like it was an odd function, this is neither even nor odd. A function can still have symmetry, but not be even nor odd. So right here, we had 3 problems. I want you to try each of these problems. Okay? Then I'm going to get the answers up here in just a second. All right, so you might notice from the graphs on our first function and our second function, you probably did fine with that, but you might have had a question on the second function, g of x equals 4 square root of x. So here's the thing. If this were an even function, we would expect something that did that. If it was an odd function, maybe something that did that here, like that. We don't have either of those things happening. So straight from the graph, you can see that it's neither. But if you're checking algebraically, which you need to do, g of negative x equals 4 square root of negative x. And what you're looking at here is that negative. We're taking the square root of a negative value, or what could be a negative value. We don't know. And so whenever we have the square root of a negative value, we get a non-real answer. So we're going to exclude that from our domain. And since there's nothing else included in our function, there's nothing else to simplify, which means this function doesn't simplify to say any of what we need it to say, either negative 4 square root of x or 4 square root of x. The exact same thing. So we're going to say, all right, this is neither even nor odd. All right, now we have these three. All you're going to do here is the exact same thing that we were doing. Testing for symmetry. Is it even, odd, or neither? Answers are coming in just a second. All right, so here we go. We have our answers up. Did you get these correct? If you have, you might have a question on this first one. So this first function, a here, we're looking at this. I think your graph is going to come out. It looks something similar to that. So what you might think is, yes, there is symmetry. Look at this line of symmetry. It looks so good. We have that line of symmetry going. It folds right over to the other side. Well, it does have symmetry. However, it is neither even nor odd. In fact, that would be a better answer to say than no symmetry. Say neither. And neither here. We're not talking about the symmetry of the graph. We are talking about, is the function even or odd? The function is neither even nor odd in this case. Then our second one is even, and then our last one had neither even nor odd. So here's a piece of art that I thought was interesting. Think about what kind of function this could be. I know it's not a function, but this is a piece of art called Dyslexia by Scott Kim. And what I want you to notice is that this is an even function. It is a reflection over the y-axis that we have right here. So we have this reflection over the y-axis. All of my x values stay the same. Sorry, all of my y values stay the same, but my x, this is a negative x, and then over here we have a positive x. So that's exactly that symmetry that's happening, making it an even function. And at this point, I'm going to want you guys to think, okay, how can I apply what I did to kind of create these graphs? So on all three of these, I'm going to want you just to do these yourself. Bring them into me. And if you bring them into me, I'll be able to go over them with you. I think these two, the first and the last one, people didn't really have a problem creating those graphs because it's an even function, and this one is respect to the y-axis. In this one right here, the second one, a lot of people seem to struggle, and it was mostly talking about the x and the y values. So if you need help with that, come see me in person. I don't want to leave you without that I don't want to leave you with that misunderstanding of what's happening in this one, in the second graph. So definitely come in and get some help if you need it. And notice here we're saying it is symmetric with respect to the origin. So there's actually multiple answers, but I want you to be thinking about specifically an odd function. And what you should always be doing at the end of your notes is taking a summary of what we just learned. So that was even and odd functions. How do you find them? What are you doing for both of them? What's similar? What is different? So go ahead and make that summary, and then go all the way back, and we even help you in your summary. Go back to this essential question. How do you describe symmetry of functions verbally, graphically, and algebraically? Can you answer that? Can you answer that without looking at your notes? That's the point where you need to be. Again, if you need any help, I'm Mr. Hernandez, and I'm always here to help.